Okay, so I'm back to this last problem here. I thought about it a bit and I don't really have any insight on how to do the big case, which is n equals to 50. But when n is equals to 5, it's easily brute forceable. I mean, the first row, there are 120, 5 factorial, 120 different possibilities. So in the very, very worst case, it's 120 to the 5. You can bring it down to 120 to the 4th, because once you have the top four rows, the fifth one is forced. But of course, after you generate the first row, the second row you can prune a lot, and then the third row you can prune even more. So this should be good enough to just exhaustive search. So, there's nothing really that exciting here. The only thing is maybe to show you how I would code this quickly. So here we are. Let's do the standard stuff. Int t, c in t, for int I equals to 1, I less than t, I plus plus, case I, and then do something. Okay, so that's the standard template, and then my soft would do something. Okay, so what am I going to do? I'm going to read in N and K. I'm going to make them global so I don't have to worry about passing them back and forth. And then, well, I'm just going to do this with exhaustive search. So search. What do I search? I probably need an array. And just pass in A. I'm going to pass in basically which row I'm working on. And this is going to return true or false if it's found or not. So if it's not found, see out impossible. And that's it. Else, see out possible. And then what is the format? I don't remember if Google cares about exact spacing or not, so let's just be safe. And that would be it, printed out. So I guess the question is how do I write this exhaustive search? Just put that like this. Actually, I don't have to provide the first dimension, but who cares? And then what else? Row. Okay, so if row is equals to n, then I guess I just sum up. That's it. I can actually do this a bit smarter, I suppose. I could have saved a factor of n here, just adding the sum at the end. I could have keep on accumulating diagonal entry and pass it to the next as a parameter, and then I can save myself a loop. At the bottom, I can also stop with one row to go because the last row is completely determined, but it's so small that I'm not going to care. Okay, and then basically, I'll just call it you have an n. are my entries, and then I'm just going to try all of them. Right? And then I'm just going to say for int j equals 0, j less than, and j plus plus. I'm going to check that every column, there are no duplicates. For int I equals 0, I less than row, I plus plus. Good. And equals a I j not equals to a row j. So that just makes sure that all the entries for each column, all the entries above me are different than me. Again, I suppose I can break out of the loop early as soon as good is false, but I'm not going to care because it's so small. And then once I find a row, I'm just going to recurse search a row plus 1, and if I found it, return true. And if I've gone through the whole thing and I don't find it, I return false. Oops, what did I do? I pressed the wrong key. So upload file, easy. Select language G++. So let's run the test and see what happens. So there are lots of places where I am not really doing things very efficiently. Clearly something is not right. Anyway, there are lots of places where I'm doing things very inefficiently, but in some way I couldn't care less. Okay, so let's see. You're reading N, you're reading K. So if I reach the last row, if I've gone past the last row, I just check the diagonals and see if the diagonals are the same. Otherwise, I'm going to take this 1, 2, 3, 4, 5, and even if it's smaller, I will do only the first n entries, and then okay, there's too much singing in the background here. Let me just go and mute this for a bit. Okay, so I found one bug, which is that I computed whether it's still good, but I forgot to actually use it. But that should not fix the bug. I'm pretty sure it won't fix the bug because I'm saying impossible when in fact it's possible, and without this flag it'll actually make it possible more often. But let me just upload it, and I'm really sure that it's not going to fix any bugs in terms of the output. It will tell me the same thing as before. Yeah, exactly. Okay, so what did I do wrong? So this checks that everybody in each column, the new row has something that's distinct from before. So somehow I'm returning false all the time. Well, this is not going so well for some reason, so I guess I'll just print it out. Oh, because I am stupid. I need to move the check later. So just as I was about to print out some diagnostics, I discovered a problem. Which is still not giving me the right thing. So let's print it out. I guess I'll run it locally. What is going on? Whatever I'm doing something horribly wrong. Horribly wrong. row. Oh, I'm an idiot. I never put B into A, so A is just completely uninitialized. Okay. That looks better. And then 2, 3. It's impossible. Okay. That's somewhat embarrassing. Just very embarrassing. I blame it on the singing in the background by my daughter. Okay. So what happens when I try to rush it when I have a small amount of free time? Okay, is it more or less the right format? 1, 2. Okay, it's a different Latin square, but it's still valid. So, okay, let's send that in. Yeah, there are many places in my exhaustive search that I could have done much more efficient things, but because things are so small, I really didn't care. So, for example, instead of doing this sum at the end of every single Latin square, I could have just removed effective n by basically every step summing the diagonal and keep a running diagonal sum. I could have stopped one row earlier because once I know the first 4 rows, it would have determined the last row anyway. So if I do a lot of those things, things are running. So maybe I actually do need, maybe it is too slow even without that. So I guess I'll try this on my machine. 5, and I guess you'll do 15. Okay, well, I guess it is too slow. All right. So in that case, I guess I better do something. Okay. Oh, it actually was in time. Okay, well, I'm going to try to make things a little bit faster then. So try to do things by effective and by basically this will speed things up by effective and but in the other cases, actually I can also reduce it by another factor, and the idea then is sum equals to, so if I do this, that will basically tell me all the numbers from 1 to n, and then I'm going to subtract out everything on top in the last column. Oh, actually, it's not clear that it was too slow before. I just didn't enter the things correctly. Okay, let's revert to the old one because it may be okay. I'll just revert back to what I had before because I did not enter the input properly. Because the first number is the number of K, so it was just actually sitting there waiting for me to do input. Now, of course, I'm trying to undo my changes. Okay. So that doesn't matter. 100 Ks, 5 and 15. Yeah, actually, it's really fast. Okay, yeah, I didn't think that I would need to worry about making things faster. So that's basically the, after a lot of fumbling, that's how I did my my last problem, the easy case.